Section 7.5 Formulas for Integration. Okay. In this section, we're going to see the familiar the formulas for the integration. Here is a table. The constants of integrations is skipped. For the integral of x to the n, the antiderivative of x to the n is this. Antiderivative of 1 of x is ln of x. Antiderivative of e to the x is equal e to the x. And antiderivative of a to the x is a to the x over ln of a. And the antiderivative of sine x is minus cosine x. And derivative of sine x is cosine x. Derivative of tangent x is secant square x. Derivative of minus cotangent x is secant square x, like this. And integration, antiderivative of tangent x is ln of absolute value of secant x, etc. Integral of dx over x squared plus a squared is 1 over a arctangent x over a, when a is not equal to 0. These are the some examples of integration formulas. Okay, here are a couple more on those. Actually, there is no universal set of rules that tell us exactly what to attempt for any arbitrarily given integral. But here is a guide for those techniques. Our strategy for integration starts with the following. The first strategy, use algebraic manipulation and or trigonometric identities to simplify the integrand as far as possible. That's what we're supposed to do first. Okay? Next, determine a suitable substitution in the integrand whose differential also occurs in it. And classify the integrand and integrand according to its form. Okay? For example, if f of x is a product of powers of sine x and cosine x, tangent x, and secant x, etc., then try trigonometric integration. If of x is a rational function, then method of partial fractions can to be used. If f of x is a product of power of x, then try out the integration by parts. When certain radical appears as a part of an integrand, such as this, then use a trigonometric substitution. Okay. If this type of integrand occurs, then use the rationalizing substitution. Okay. Last, 4. If the first 3 cases do not lead to the answer, then basically only 2 methods of integration, the substitution rule and integration by parts, are to be used. When no substitution is obvious, try an appropriate substitution. Integration by parts may be used and relate the problem to previous problems. Relate the problems to previous problems. Refer other problems to solve your problems. And use several methods together. Okay, here is the examples. Find this integral. In this case, this can be written in this way. So, the integral is now of the form of this with n even. In this case, the substitution can be properly used to get what you like to have. Yes. And for this case, the substitution of square root of x minus 3 as u, that gives us dx is equal to du 2u du, which makes this given integration to be in this form, which this arctangent can be easily used as an antiderivative of this. And for this type and for this one, since the degree of the denominator is greater than the degree of the denominator, so we perform the long division and apply method of partial fraction. Like we said, the Chinese remainder theorem can be used on this and then apply the method of partial fraction. Okay. And for this, the substitution for ln of x for u can be applied to simplify the given one to this by using the integration by parts. Then it's getting simplified once and twice to get what you like to have. For this, and multiplying the denominator and numerator by square root of 2 plus x, which can be simplified in this way, then we can think the antiderivative of this form without much difficulty. And for here, if we substitute this, then this term of the integration can be easily solved with the many diverse ways, including the simple substitution. And also the techniques for rationalizing in this form of the function, and because if u can be written in this way, then x can be written in this way, and dx can be found in this way. And this substitution can be properly used to deal with such a integration. Get it? But eventually, we call what? Polynomial, and rational function, and power function, and exponential function, and logarithmic function, and trigonometric and inverse trigonometric function, and hyperbolic and inverse hyperbolic functions, and all functions that can be obtained from these by the 5 operations of addition, subtractions, multiplication, division, and composition are called elementary functions. Elementary functions. Okay. And are the objects to be differentiated or integrated in calculus course. Okay. If f is an elementary function, then f prime is also an elementary function. But integral f of x dx does not need to be an elementary function. For example, this indefinite integral cannot be expressed in terms of elementary functions. Okay, this is a very typical example, which is not elementary. Okay, also the following functions cannot be expressed in terms of elementary functions as well. So integrations has very many diversity. Okay. Particularly in this chapter, we are recommended to use CAS tools to deal with it after we simplify the given function as much as we can. Evaluate the integral of this. Then the partial fraction can be used, and then integral command gives us the answer on it. Okay, so most of the problems which was introduced up here also can be dealt with the most well-known CAS tools, including SAGE. So here is the exercise problems for section 7.5. Okay, so most of the problems are already solved by SAGE command. So you may try some more interesting problems that you may think. Here is a field medalist, Yao, and his advisor, Xingsheng Chan. Okay, I think that's it. Any questions?